Covalent bonding. Whenever an atom forms a compound, its goal is to get a full, stable outer shell of electrons. And as we know, that means it follows the pattern of 2, 8, 8. 2 electrons in the first shell means it's full, 8 in the second shell, that's full, 8 in the third shell. In order to do this, they've got a few different options. They can form an ion, which involves gaining or losing electrons, which is great. But what if we want to bond a non-metal with another non-metal? Well, non-metals, except the noble gases, of course, non-metals, when they form ions, they form negative ions. That means that they gain electrons. If they're reacting with another non-metal, for example, hydrogen with hydrogen, oxygen with oxygen, or carbon with oxygen to make carbon dioxide, they have nowhere to get those electrons from. There are no metal ions present that will give up their electrons. So instead, what they have to do is share their electrons. And a covalent bond is very simply a shared pair of electrons. What do I mean by that? Well, I have an example over here, which is 2 oxygen atoms. Now, you probably know oxygen is a diatomic molecule with the formula O2. It is like that because each oxygen has an electron structure of 2, 6, 8 electrons in total. A full first shell, but in order to make a full outer shell, it needs to gain 2 electrons. If it is reacting with another oxygen, it doesn't have anywhere to get those extra electrons from. And both oxygens want 2 extra electrons. So what they can do is they share. Their outer shells overlap, and these electrons are shared between both oxygens in this example. This is a double covalent bond, as shown here, because each covalent bond is one shared pair of electrons, and there are 2 pairs here. We draw them with these dot and cross diagrams to show which atom each electron came from. And if I count the outer shell electrons of each of these oxygens now, I've got 1, 2, 3, 4, 5, 6, remember these count for both, 7, 8, full shell, happy oxygen. 1, 2, 3, 4, 5, 6, 7, 8, full shell, happy oxygen. That means they've both got full shells, they've got 2 shared pair of electrons, giving it a double covalent bond. Each line that you represent like this is one shared pair of electrons. So a hydrogen molecule has a single covalent bond which shares 2 electrons. Oxygen has a double covalent bond which shares a total of 4 electrons. Nitrogen, a very strongly bonded molecule, 3 covalent bonds which has a total of 2, 4, 6. Okay? We call the number of bonds that each atom can make its valency. I'll show you with a compound now instead of with an element. A very common compound, it is water. So if I draw the outer shells only of each one, I'm not going to draw the inner shells, hydrogen has 1 electron, which means that it has 1 electron on its outer shell. If it wants to make a stable outer shell, it needs to gain 1 electron, or it can lose 1. Hydrogen, of course, can make positive ions. But the oxygen needs 2. So it takes 1 from each hydrogen and also gives 1 to each hydrogen to give it this Mickey Mouse look. 1, 2, 3, 4, 5, 6, 7, 8. So to recap, a covalent bond contains a shared pair of electrons. It happens between non-metals, and the finished product gives each atom a full outer shell.